Welcome all of you to this video. In the previous video, we studied about the area of the sector of a circle. Today in this video, we will study about the area of the segment of the circle. As you know, that a chord divides the circle into two parts in which one part is bigger and the other is smaller, where larger part PSQ is area called the major segment and smaller part PRQ is called the minor segment. Come, let's find the area of the minor segment PRQ. For this, from the center O to the chord PQ, draw radii OP and OQ,
where the value of angle POQ assumed to be theta.
Observing the figure carefully, we can say that the area of sector OPRQ is equal to the sum of areas of segment PRQ and triangle OPQ. Since we have to find the area of the shaded region, so from the area of the sector OPRQ, area of triangle OPQ is to be subtracted, which is represented by equation 1. For the area of a triangle, first the base and height have to be found. For this, we draw on PQ a perpendicular OL, which makes triangle OPL congruent to triangle OQL, and from the corresponding part of congruent triangles, that is CPCT, we determine that angle POL is equal to angle QOL. The value of angle POL and angle QOL is theta divided by 2. In equation 1, the formula of area of sector is theta upon 360 multiplied by pi r square. And the area of a triangle is 1 upon 2 multiplied by base multiplied by height, where the base is PQ and the height is OL. Now if we talk about triangle OLP, we know that cos theta upon 2 equals to OL upon OP. From this, we get the length of OL as r cos theta upon 2. Similarly, the sin theta upon 2 will be equal to PL upon OP, from which the value of base, that is, PL, is found as r sin theta upon 2. That is, we know that in the triangle OPQ, the value of base PQ is twice that of PL. Hence, the value of area of triangle OPQ is r square multiplied by sin theta upon 2 cos theta upon 2 is what we find. By placing the above values in equation 1, the shaded part area of the segment PRQ, r square multiplied by theta upon 360 times into pi minus sin theta upon 2 into cos theta upon 2 is what we get. In this video today, we learned about the area of the segment of the circle. In the next video, we will see some interesting examples based on this concept. Welcome all of you to this video. In the previous video, we studied the area of the segment of the circle. Today, in this video,
We will see interesting example based on this concept.
in a circular garden,
Plant flower beds leave a hexagonal part of a circle.
if the diameter of the garden is 40 meters, find the area of that part of the garden in which the flower beds are planted. Come, let's try to solve this. As you can see from the figure that there are 6 flower beds in the garden. According to this figure, there are 6 segments in the circle. Since it is given that the diameter of the garden is 40 meters, therefore, the radius of the garden will be 20 meters. So, we can say that the angle subtended at the center by each sector will be 60 degrees, which is represented as follows. Let's now talk about triangle AOB. Here we can see that OA is equal to OB, so the angle OAB and angle OBA will be equal. But can you tell what will be the value of angle OAB or OBA? Absolutely correct, since we know that the sum of all angles of a triangle is 180 degrees. Therefore, the value of angle OAB or OBA will be 60 degrees. So, we can say that triangle AOB is an equilateral triangle with all sides equal. Since we have to find the area of the segment, therefore, from the area of sector OAPB, the area of equilateral triangle OAB will be subtracted. In the formula of area of the sector, when values of theta and radius are placed and solved, the value of sector OAPB is found to be 209.52 square meters. While the area of the equilateral triangle, putting the value of the sides as 20 gives the value of triangle AOB as 173.2 square meters. On solving which, the area of the segment APB is 36.32 square meters. That is, the area of each flower bed is 36.32 square meters. Therefore, we can say that the area of the total flower beds is 217.92 square meters. In this video today, we saw an interesting example based on the area of the segment. In the next video, we will understand another interesting example in depth. Welcome all of you to this video. In the previous video, we saw an interesting example based on the area of the segment. In this video, you will see another interesting example based on this concept. In a given circle of radius 14 centimeters, XY is an arc of the circle, which forms a right angle at the center of the circle. So can you
Find the area of minor and major segment.
here use the value of pi 3.14. Pause the video to solve the question and then match your answer. Come, let's see. The formula for the area of the minor segment is R2 multiplied by pi upon 360 into theta minus sin theta by 2 into cos theta by 2. According to the given information, on putting the value of theta in R, that is, radius in the formula, and solving, the area of the minor segment is obtained as 55.86 square centimeters. Since we have to find the area of major segment along with area of minor segment, so can you find the area of the major segment? Absolutely correct. For this, from the area of the circle, the area of the minor segment is subtracted, where the area of the circle is 615.44 square centimeters and the area of the minor segment is 55.86 square centimeters. On solving which, the area of the major segment is obtained as 559.58 square centimeters. So, we can say that the area of the minor and major segments in the circle are 55.86 square centimeter and 559.58 square centimeter. So hopefully, you must have understood how we can solve these questions easily with the help of the segment area formula. Teachers can also test the understanding of the students with the help of such examples.